I'm going to change the settings here. These settings are not happy, but we'll try anyways. Okay, Lady Ada.
Hello.
It's the desk of Lady Ada.
Oh, it's me. I'm at my desk. Look at me, all typing and tronicsing and tweezering. Yeah, we're doing a video test, right?
Yeah, we're doing a video test.
Okay.
I gotta try some other stuff.
Yeah.
Okay. So why don't you give everybody a tour?
Okay. Should I do the getting up part?
Yeah, do the getting up part.
Okay. Here, I'll come around this way.
Okay, where are we?
Hey, we're at the Adafruit factory, 10th floor. It's me, we're here. I thought we could go around and show some pick and place parts. And we can also show off
special bonus, we'll put the live chat in so people can ask questions.
Oh, yeah. They say I'm quiet. That's not true at all.
Okay, well, try and talk.
Hi, hi, hi.
All
Testing, testing. Okay, so let's go this way. We'll go past Dano's desk, Vance's desk. Vance is reworking machines king. Dano is tester maker.
Yeah.
This is this cool thing we just...
We'll check back in the chat in a second.
We just built. See if I can turn this on.
Turn it off.
Yeah. I'm just plugging stuff in. This is a panel that didn't get depanelized, but it worked. It like went through the pick and place. Oh wow, this looks more. So it's got like, it's running Game of Life. It's kind of cool. So these are all little Charlie wings that tested, but we couldn't remove them from the panel. So we'll let it hang out here. Okay, great.
Okay, let's go look at the stencils and the other stuff.
So all the pick and places have parts on reels. These are some of the big feeders we have. Oh my goodness, this is so heavy. This is like a 44 millimeter feeder, 44 millimeter wide tape. These are like $10,000 each or something ridiculous. They're very expensive. I mean, I think like they're worth it, but you know, you use them for a very long time, but they're chunky, but they're like for big feeders like this. And then this is where we keep our feeders. Little feeder storage land. So like this is an NXP, what is this chip? Let's find out. This is the, PN532. So this is the NFC chip, and then we've got some inductors here and some capacitors. Capacitors come on like these lower cost cardboard reels, but chips come on nice plastic reels, sometimes on anti-stat reels. Got all of our stencils. Let's see if I can pull one out. Oh my goodness, these are, there you go. Stencil. Stencil's coming at you. You can see all the holes. It's also very shiny.
Yeah.
Maybe you can see Phil.
Hi.
Hi. I'll put this back. Stencils that go into our stenciling machine, so you can paste them.
Okay, you want to show the rest of the stuff?
Up. Yeah.
Okay.
So this is, oh, you can see tomorrow. Look, this is, you can even see what we're making tomorrow by looking at the stencils. So, Fona 808 is on the list.
Here's some questions from the chat.
Yeah.
Do we recycle the reels?
Reels do not get, well, they get plastic recycled, but they're not like recycled
You can't put more parts on them.
as reels. You know what I mean? They're like melted down. And then we're making the Trinket M0. You can see it's upside down, but you can probably still read it. And it's a super clean stencil. It's like the cleanest stencil because it's never been used.
Yeah.
So this is the Trinket M0s. Are very small, but we're going to make, I think we make, what, 30 at a time, 28 at a time or something. So that's tomorrow's work order.
Okay.
And then inside the machine, we have the Trinket 3 volt. So we have a stencil in here. I can't pull it out because it's locked in, but that's a stenciler.
Trinket M0, everyone's Trinket M0.
Everybody's excited, I know. I'm actually, well, I just actually tweaked the tester right when you were talking to me. I'm making it so on Macs, it doesn't create those like F7 STD whatever files, like very annoying. So I'm putting some, I'm touching some blank files that'll tell the file system not to index. And then this is pick and places. This is the 482, the original. Samsung. Next to it, we've got the 481.
Why are the stencils so big?
It's a standard size, you know. It's like they pick one size because it has to be. You have to pick one size and stick to it, and so I think they just decided 2 feet by 2 feet, and then everyone sort of decided, okay, that's the standard size because like that's as big as you're going to get.
Yeah.
It costs the same amount. It doesn't matter. Like it's not like it's cheaper to get them smaller. Like the cost is in the processing and not the like materials.
We used to hand stencil. They were smaller because we had a little tiny hand stencil.
Yeah, we did. I don't think we have those stencils here anymore.
Yeah.
Oh no, we do. We have them over there, but they're hard to find.
Not within range of going over
Yeah,
there.
and this is our inspection station. So we've got our inspection booklet. You can see we made some trinkets, and then let's see some other boards. Very nice. So very nice pictures that we use are also really handy because you know, we can use them for optical inspection because they're such good photos. You can see the dots and the orientation. I mean, it's rarely an issue. Usually parts come on the feeder in the order that they come in, but that's not always true. And then there's just the oven. This is a testing station. So we use like this really old Mac. This is Phil, this is your Mac.
Yeah.
This is such an old Mac. It's got the old round style. This is gigantic. This feels like it's from the 70s.
This is one of the first things I laser etched.
Yeah, you laser etched this. Beautiful. And then we use this for testing. It still works. It's just not good for, you know, using anything. But for some, I think for some products, we still use it once in a while.
Yeah.
Although we've moved almost all of our testers to Raspberry Pi. So actually, here's the Trinket M0 Tester. And you can see it says on the bottom, Trinket M0. And it's a Raspberry Pi based tester. And so the Raspberry Pi actually does, these are the GPIO
Look
wires.
to the camera and see how close you can get with it before it freaks out.
Yeah, that's
Okay.
not so bad.
That's pretty good.
Yeah, and so it's SWD programs the chip, and then this is the clamp that holds it down while it programs, and so it programs and tests it. Although, some really good news, Dean today got FreeDAP, which is this project to turn at SAMD 21 into a SimSysDAP device. We got it working standalone. So we'll be able to program trinkets and gemmas without needing a Pi, which will really speed things up because OpenOCD, like you just add OpenOCD and everything just kind of melts it down. Speaking of melting down, here's the oven. This is the end of the oven, nitrogen generator, compressor, oven, parts come out
I'm gonna try to do
here.
something terrible midstream.
Okay, you want to do something terrible?
Let's see how much I mess this up. Yeah, I know.
Whoa,
Let's see what I just did.
okay.
So I'm gonna try something.
Seems to be,
Yeah.
okay. Oh man, you're changing resolutions midstream.
Yeah.
Risky,
Super risky.
mega risky.
Okay.
Over here we have the, here's some of the trinkets that we made. Not the M0s, these are the classic trinkets. We're gonna still sell these because, you know, some people really need original trinkets, but hopefully we'll slowly get through them. I mean, they're gonna be a little bit less expensive maybe because the chip, these chips cost 50 cents and the chip in this Trinket M0 is $1.50, so it's kind of hard to make it the same price. We can see this panel of trinkets, blue trinkets. So those are ready for testing. We'll do that next up. And
Yeah,
then,
let me see what the chat's saying.
yeah. So hoping to see the NR52 Pro stencil. Oh, it's kind of like the Trinket tester, but it's got more holes in it. And then over here we have the Selective solder machine, which is always on because it has a gigantic tub of solder in it. It's toasty. It's like a fondue pot, but for solder. You dunk boards in it basically, or the boards sort of dunk themselves. And then it does all the through-hole soldering. Over here we have all the through-hole parts. So like Ethernet jacks and like, you know, those little joysticks, those are selective soldered. We place them in by hand, and then they're selective soldered. And then we have a whole cleaning area just for that board. Here's a quarantine stuff that needs checking or testing or something's weird with them.
Okay, that's as far as we can get with that.
Yeah, and then
Let's go over to the desk over here.
the desk. Oh
Yeah,
yeah, we can
still
see what
working on stuff.
Asher and Brent are working on. So this is Asher and Brent's desk. They've been working on, oh, this is, looks, it says Circuit Python RGB test. So that's kind of cool. So yeah, they're working on some Circuit Python codes. This is a Metro Express, and it's running CircuitPython, which is kind of cool. Doing some LCD stuff. And just all sorts of Metro stuff. Tomorrow is their last day, but they did a lot of cool stuff with CircuitPython and Arduino.
We don't do lead soldering, so we don't have to worry
this
about
is
that. And
it's
we
all
also
lead-free.
have a filter system, which you can see in the back.
Yeah, that's our filter. Although, you know, the ovens, when you get good ovens, they have a flux collection.
Yeah.
But yeah, we do lead-free, so it's all tin and a little bit of silver, copper, and I don't remember the other majority chemical, but there's no, we're lead-free. We've actually been lead-free ever since we had a pick and place. From before, you know, like before the pick and place, I would do some lead soldering, but now everything is lead-free here. Just easier that way. There's no reason not to. You know, like, there's no benefit really to leaded solder. You might as well just get your process good enough with lead-free.
Okay.
All right, cool.
Yeah, someone asked, where's our arcade that we're building? It's in the back. We're still
It's in the back. We're still building it. We wanted to get stuff in stock.
Yeah.
So, but we're doing good. We're like 96% in stock.
Yeah, we can work on other stuff, but can we show you how big it is inside the TARDIS? Not with the amount of cabling.
Yeah, we
so
can't
this
reach
is
the
all
TARDIS.
this is all actually on a large cable because we're doing a test for a live stream that we're going to be doing tomorrow. Mm-hmm. So
yeah, that's what we're doing. We're actually testing.
Yeah, we can't reach back all the way there. Right.
Okay, and then we're going back.
Yeah.
The Game of Life is still playing. Here's another board we made. This is another panelized board. Let's take it about a foot away. It's easier to manufacture when you get a bunch in a pile. And then, I don't know what this is. Pile of boards. These are like rework boards, so we're reworking some. Some are like rejects. We use rejects for two things. Well, one, we try to fix them if it's like, oh, there's just a pin that needs to be soldered or something is bridged and we can clean it up. So for that we fix it, but we also use it to analyze our testers, because when I designed the testers, I designed with only like 2 or 3 boards in mind. Like I only have 2 or 3 boards made. But as we test, thousands and thousands of boards, I find better ways of testing, like, I hit the edges. So, for example, I redid this Feather Phona tester today because the Bluetooth scanning I was using was kind of flaky. So I researched, found another way, and we're going to try updating this tester and having people use it, see if that gets the yield higher. Because otherwise people have to retest them, and the Feather Phona and the Phona boards in general take a long time to test because you have to connect to the cellular network. And that always takes, 10, 12 seconds, and you kind of can't do anything. You're like waiting around. So getting that sorted out would be good. And then this is the handmade Trinket. I can show this off. This is the first one. We made this by hand from the panel. A nice silk screen. Yeah. Cool. That's kind of it.
That's everything.
Yeah. We
All
got
right.
to everything.
Well, thank you, Lady Ada. This was a good test. Thank you.
Good. Yay. Thanks, everybody, for watching. I'm going back to my desk, and I wrap up this Feather Phona tester.
Yep.
All my code for testers is committed to GitHub, so after I make changes, I have to commit it, and
Everybody
then it's saved.
in the Discord chat, say hi to Lady Ada. Say hi and bye.
Hi. Bye. Goodbye.
We'll give them a few seconds to type it in. Put neat emojis in the chat.
Yes, be nice. Send hearts.
Yeah. Bye. If you click the little emoji thing, we have the Adafruit emojis. You could put Adabots and stuff like that.
Commit and push. GitHub is so great.
Yay, look at the Minerva.
Oh yeah, that's a nice little owl.
Isn't that cool?
Thank you for the owl. All right, I just updated my Trinket tester. There's a snake.
All right. Bye, folks.
Okay, cool. Bye, folks. Thank you for watching.
Bye-bye.
We'll do more tours.